Let me be sure. So I'll just check my stream again. Let me be sure. So I'll just check. Okay, I'm live and we're good to roll. Okay, so today I'm just going to solve one question quickly. It's a medium. It's a medium. Um, what was I, what was I going to say? It's a medium linked list question. Sorry, and this question is actually somehow it was not difficult for me to think about really, because yeah, I mean, this is, due to the practices I've been doing on linked list so far. Anyway, I'll just implement the solution. But before I do that, I need to explain what this is about. So we have a so this is LEETCODE 281 merge node between zeros, right? So you are given the head of a linked list which contains a series of integers separated by zeros. The beginning and end of the linked list will have node val, right? The value of the node equal to 0. For every two consecutive zeros, merge all nodes lying between them into a single node whose value is the sum of all the merged node. Okay. The modified list should not contain any zeros. Return the head of the modified linked list. So here's an example. We have a linked list, right? The start of the linked list is 0, the end is 0, and we're asked to merge everything in between, right? So we are going to merge 3 and 1, and then this will give us 4, and every other node in between zeros and 1 on the other side as well. And then we'll return uh, a new head, right, where the first sum, right, between two consecutive 0 is the head of um, our new linked list, or the head node, right? So basically we have a head, right, that is in this form. This is the shape of our linked list, and here's what we did. So we summed up everything between these zeros, returned it as one node, right? And then we did the same thing here, return it as another node. So the figure above represents the given linked list. The modified list contains the sum of the nodes marked in green and the sum of the node marked in red. Okay. Yeah. This is quite uh this is a good question. So I'll just, as usual, let me just explain what we are going to do and how I thought about this question. So I'm just going to increase this a little. Right, right, right. Yep, and that's about it. I'll just use my pen. Where's my mouse? Okay. Hold on. Okay, so now there are two reasons why. There are two reasons why this question uh, might seem easy, because all we need to do is to um, okay, let me just go ahead and do this. Now we have this our linked list, right? This is the linked list we have, and we want to return the sum of every node between two consecutive zeros, right? And this sum here is what we return at the end of the day, right? We return this sum as part of a new linked list that we want to uh, return. So since this is the first sum we'll perform at this stage, right? 3 plus 1 is going to be equal to 4. So all we need to do is to iterate through the linked list, right? We'll start from the head, we'll traverse the linked list from this point all the way to the end, right? And for every for every zero we encounter, right, we'll know the next node will be a number. So we'll begin to calculate, we'll begin to add sum every value between the zeros, and every time we see another zero, we'll just return the previous calculation we did into our new linked list, right? So these are the steps we need to follow. The first step will be to create a new head, right? So we'll create an instance of a new head or a new node. So I'll just I'll call this my final node, right? Fn, or final head. And then this will be, an instance of a node, not an instance of a node. This will be a linked list. So I'll instantiate this. Yeah. So we'll do it this way, right? And then, every time we add an item to a linked list, right, if there's no head, the new item becomes the head. So when we are iterating through, or we are traversing, I think using traversing is better for linked list. So when we are traversing through our linked list, from our original linked list, from the head all the way to the last node, which is the tail, right? At some point we will see some zeros, right? The zeros act like borders, right? The zeros will act like borders, and we'll need to then sum everything that is between those zeros, right? So in our first iteration, here is what we need to do. In the first iteration, we could start with this 0, right? We know when we see a 0, it means we'll probably have the next item as an integer or a value that we can then begin to add until we see another 0 again. So every calculation we do here, right, we'll then add that to this linked list here. So let's say, for instance, in the first iteration we see a 0, right? We see a 0, but then we set the current node, right, with current node to the next node. So this will look to the right of this first node here, which is 0, right? We'll look to the right of it and set the next item, right? So the next item is going to be 3, or the next node is going to be 3. We'll have a value of 3, sorry. The next node will have a value of 3. Then we'll take this 3, right? We'll do 3, and then we'll look to the next side of this 3, right, and see a 1, right? So we do +1, and then when we meet another 0, right, we'll already here, let me call this I'll call this sum. Already at this point we've already done 3 plus 1, right, which is equal to 4. When we see a 0, right, which is another node, the node next to our last node, then we'll just take this value and add it to our final node, right? So we'll do final node dot add, right? We'll add this to it, right? Already we would have defined this function. This function will always check if there is already a head in the node before adding a new node to the if there is already a head in the linked list before adding a new node to the linked list. So 4 will be then added to this node, right? And then we'll reset our sum back to 0. Our sum will be reset back to 0, and then we'll continue. So after seeing a 0, right, we'll reset our sum back to 0, and then add our value to it, right? Or we add the sum to the the linked list, right, this fn here, and reset our sum back to 0, so that we know the next items we see, I mean the next node we will look at is going to be 4. So we'll do again, we'll say sum is going to be equal to 4 plus 5, and every iteration we will look to the right of the current node or the next value of the current node, and then we'll get a 5. The next value of 5 will be 2, right? So we'll do plus 2, and this will be equal to, this is 6, so 11, right? And we'll then meet a 0 again. So at this point we take our sum that we've had so far and we add it to our final node here, right, or final linked list. So this will be fn, sorry, we'll do fn dot add, right, add, so we want to add the new node that we the new total, the new sum that we have. So this will be 11, right? And at the end of the day, our final node will look something like this. So if we run a print function on this final node on the head, right, we'll have, this will be equal to 4, 11, and none, right? Now the question is asking us to return the head, right? So we'll simply do return fn dot head, and this is all we need to do to solve this question. At least I've not run my solution on LeetCode, but I think this is a simple way I've thought about it. All right, so I'll just take this, right? Let me see. As usual, I'll copy. You know what? I don't want to copy everything from here. I will implement the solution from literally from the start all the way to the end, right? Because I would like to set up everything myself. So let me see. I'd done this today, but I'm just going to do it over again for you to actually understand how it works, right? So let me see. I will delete this, and so I'll create the, what do I need to create? Hold on, what's the name of this? Merge node. So I'll call this merge node. So it's going to be in linked list. I've done merge to linked list before. Surprisingly, merge to linked list was more difficult, even though it was an easy question. I don't know how the ranking, the difficulty of questions are made in LeetCode, but merging to linked list was actually more difficult than this. Anyways, I'll just say merge. Is it what's it called? Merge nodes. Okay, so new file, new Python file, merge nodes. Okay, so here's our merge node function. First of all, we'll need to create our own custom node, right, and our own custom linked list to be able to test this out locally. So I'll implement a linked list, but first of all we need a node. So this is going to be node. This is our linked list node anyway. Instead of calling it node, right, I'll call this list node. Yeah, so I'll call it list node instead. So node, I'll say lists node. Yeah, so our list node is basically the node that will be part of our linked list, and this is simply the basic units or the items that make up our linked list. So this is going to be instantiated, of course. So I'll define a constructor function. This constructor function will take the value we want to insert in our linked list, and then I'll just say what did they use in LeetCode. So I'll just mimic some things. So they used value and next. Okay, so self.val is equal to this value, and so self.next, right? We know our list node, or the node in a linked list, has two properties, which is the value and the next property. So next is going to be none, which is where we attach the next node that we want to insert in our linked list. So let's implement the linked list class. So I'll call this class linked list, right? And this is going to be instantiated as well. So define, I'll create the constructor function. We don't need to pass it a value here, so we'll need only one property for our linked list, which is going to be self.head, right? Our head is initially going to be none. So now let's define a function to add nodes to our linked list. So define add nodes, right? And this will be so we'll take so this so we want to add a node, so we'll need a value to add, right? This is going to be value, and the value will be set to the head of the node. So before we even, so we need to instantiate our new node. So I'll say new node is equal to the list node, right? And the list node expects a value, so we'll pass in the value here, and then let's check if our head is empty. So if head sorry, if this self.head, right, I can say if not self.head, right? If not self.head, or we can say if head is none, that also works. So I'll just say if self.head, and then I'll just say if the head is still none, right, we want to add our current node. So I'll say head, sorry, self.head is going to be equal to the new node, right? The new node, and then we just simply return here. So if we already have a head node, right, in that case, when we want to add a new item, we'll need to traverse the head all the way to a point where the current node will have a next value of none. So we'll say so I'll say current node, right? I'll call this current node. I'll set this to be equal to self.head. So self.head, right? And I'll run a loop to traverse. Oh my god, what's going on this network? Sorry if my network is still bad today, I don't know. So I'll run a while loop, right? So this is going to be while the current node has a next value, right? So next is not none, right? Then we want to set current node to the next node. So current node, right, is going to be equal to the current node dot next, right? And yeah, so that's all we need to do. At the end of the day, we want to get current node dot next should be equal to our new node. So with this way, we can begin to add with this function, right? With this method that is part of our linked list class, we can begin to add items to our linked list, right? So this is an implementation of a linked list. So let's test this out and see how it works, right? So before I test it, I will need a function to print the linked list for me. So I'll define that function outside of the linked list, right? So I'll call this, so this is no longer going to be part of the class. So I'll say print lists, right? And this function is going to take a head, right, which is the head of the of our linked list, right? So I'll say I like using current node. I don't know why, I just got used to it. So current node is going to be the head, right? So this is going to be our head, and we'll run another loop on this. So I'll say while current node is not empty, right? Or is not none, sorry, not empty, it's not none, then we want to set the current node to be equal to the current node, right, dot next. Now before I assign a new value to our current node, we want to print the current node as well. So I'll just print current node dot data, right? Because our current node will have a data, and we'll simply, so I'll print everything on the same line and with an arrow like this, and this will simply add arrows between each print statement. So yeah, so this is all we need to do for the print function. I will instantiate a linked list here, so I'll call this lists. I'll call this new list. Yeah, let's call this new list, and create an instance of the linked list class. So linked list, and we'll begin to add items to this. So new list dot add nodes, right? We want to add so I'll use the example we have here as my values. Where is it? Yeah, okay. So I'll use this example. So we have 0 3 1 0. Let me move this to this side and type it quickly. So we'll add 0, right? I'll copy this one. How many items? 0 1 2 3 4 5 6 7 8. So I'll do 1 oh, so this is 1, so I'll set this to 3 3 1, and then we have another 0, right? And 4 4 5 2, and then 0. Okay, so here you go. This is what we have, and we'll just print what is in this linked list, right? So all we need to do now is to just run the print list, right, and pass it the head. So this is going to be a new list dot head. So when we run this now, okay, there's an error. I don't know, I always make this mistake. Current node dot data has no attributes data. Oh, what did we call it? Oh, it's val, not data, it's val. So this is going to be current node dot val. Yeah, okay, as you can see, this is our linked list. So we started from 0 all the way to 0 again. Now So what do we need to do next? Now we can start, implementing our merge function, which is to merge the linked list, right? So to do that, we just define a merge function. I'll call this, what was it called here? Merge node between 0, right? So I'll call this merge node, right? So copy this, because I'll use this function to so this merge node takes takes a head, right, which is the value we'll provide this function. And at the end of the day, we want to return a linked list, right? Or a new node, sorry. We want to return a new node, which is, and that new node is just basically going to be the head node. All right. And we know the head is like the starting point of the entire linked list. So what do we need in this case? So I know I'll be returning a linked list at the end of the day. So I'll just call this final. I'll create an instance of a new linked list, right, to which I want to add items to, just like the way we did this here, right? So I'll call this final node, right? My final node is simply going to be an instance of a linked list. So I'll call this linked list, right, and set it like this. Okay. So now I'll begin. So I'll need a way to keep track of the additions that I'll be making between the 0 nodes, right, between the two zeros. So I'll call this local sum, right? I'll call this local sum and set it to 0. So my local sum is going to be equal to 0, and then I'll now iterate through. I'll traverse my linked list, right? So I'll say while the head, right? Okay, instead of doing the head, I'll say current node always, because I'll need to set the next value each time. So current node is equal to the head. This is something I just got used to doing with linked list, and it has been working so well. I hope it works now. So we'll call this current node. While current node is not none, right? It's not none. We'll set so while current node is not none, then we'll set it to the next node and the next node until we reach the end of our linked list. Okay, so what do we need to do? First of all, we need to check if the current node has if the current node is equal to 0, right? I'll say if current node, sorry, I call this current none, not none, is node. Current node. So if current node, right, dot data, sorry, not data, I was using value. If current node dot value is equal to 0, right? If it's equal to 0, then if it's equal to 0, right, it means we are either at the start or we've done some calculation already and we met a new node that is equal to 0, right? So what I'll need to do is okay, if the node is not equal to 0, right, we want to add every node in between and find the sum. Well, if the current node is equal to 0, right, and I'll put an else statement here. Else here. Else, we know if the node is not equal to 0, then we're at a point where we can add items to the local sum, right? Else what? Else we can okay. So one thing that is for sure, in every iteration we want to reset our node to the next value. So I'll just do current node, right? Current node is, so it simply be current node current node dot next. Now this will save us one step. So I'll know here, this is the place where I will do my calculations, right? So I'll say local sum plus equal the current node, right? The current node dot value, right? So I'll calculate the value here, and here at this point I'll reset the value of our local sum back to 0, right? So but before I reset it, right, I'll say if local sum is not equal to 0, right? If the local sum is not equal to 0, then I know that I've already done some calculations before, so I want to add those values to my final node. So I'll say final node dot add nodes, right? And I want to add the local sum to it. So local sum, then I set the local sum back to 0. So local sum should be equal to 0. And at this point, so this point here, we do all the calculations, we add new values to the local sum for every node that is not equal to 0 until when we see a 0, right? And already we have some value for, we've made some calculations here, then we can just take the local sum, add it to our final node, right? And then set the reset the local sum back to 0, which means we are ready for a new calculation, right? So yeah, and oh sorry, let me just come down here. And at the end of the day, right, we must have, iterate through all these parts. And here's what I need to do. So I want to return the head, right? So I'll say return the final node, right, dot head. Okay, so let's see what we'll have. I'll call, since we are returning a value, right, I'll call this here. I'll say merged nodes, right? Or I'll say merge nodes, yeah, results. I'll call this merge nodes results, and I'll set this to the merge nodes function, and I'll pass it a new linked list, right? So which is this linked list here. I'll pass it the new linked list dot head, right? Always. Then instead of printing this head, okay, I'll just call this print list again, but I'll print this time around the second node, the second list that we have. So print list, I'll set it to the merge nodes results dot head. Oh, I don't need to put dot head because I'm already returning the head here. So yeah, let's run this. Hopefully everything works. Let me just add some spacing to this. So I'll just say print an empty space like this. This should work. So we should have new lines. Yeah, and that's it. So we did all the sums in between every zeros, right? And we just return those nodes into our new linked list. So yeah, now we can go ahead and try to implement this in LeetCode, right? And see what we'll have coming. So oh, somebody said nice in the chat. Okay, nice too. All right, so let's go ahead and do this. So I'll just use the same idea on LeetCode. Instead, I'll just push this to the right out of the screen and we'll implement it here. So with one issue I have here is is that I can't, create a new instance of a linked list. Do I need to implement one myself? So I'll be able to add items to it. I'm not sure. I'm not sure if I should, create my own linked list. And so I mean, I can just uncomment this, right? This works fine. I can create. I think I should do that. So I'll just copy my linked list here. Although this, I'm not sure how effective this is going to be, but let's keep an open mind. So that's it, and I'll just copy here, create an instance of my linked list. So I'll put this here like this. So we need to push this inside a little. Okay, so here's what I have. Let's run this and see what's going to happen. Oh, it worked. It worked, and that is not surprising. Well, I mean, the main thing is the submission, right? Because I mean, it might work here, but the submission might not work because there's probably a case where something is missed. But let's keep an open mind and see. Okay, this is taking longer, which means there is something, maybe an error for the runtime. Yeah, I knew it. So time limit exceeded. I mean, it passed most of the test cases, right? Just when we have a lot of nodes. Wow, this is really long, and I know what. Why? Why? Why is this like this? Oh my god, this is a lot. This is a lot. What? Anyways, time limit exceeded. Does I mean it's not like the solution didn't work. Is there any editorial for like managing the time? Oh, people did quite well on this question. So 87%, 85%. Let's see what's why is this marked medium? Okay, but good for statistic. Yeah, uh, yeah. Like I said, this was an easy question. It should come in easy. Just think of how you can utilize temp pointer to modify the list. Okay, so to avoid runtime error, signed integer overflow. I mean, okay, so 2 pointers, right? So 2 pointers for current and previous. Oh, I mean, this is create an answer and stop when the counter appears. Let's see. Just having a runtime error. It's just that the function, I mean, the implementation was actually slow. So let's take a look at is there any solutions? Python 3, blah blah blah. I don't like the fact that, you know, I mean, do I need to return this here like this? I mean, I could just create, wait, I'm asked to return an array. What if I did this? Would this work? Because at the end of the day, we want to return an array of nodes, right? So each time I could just say, instead of implementing this, right? What if I just say this was an array? If I created an empty array and add new nodes to it, so instead of doing this, I'll come with, let me just try this out. Instead of, nah, this is not going to work. This is not going to work at all. I'll just say 0, right? I mean, we still need to create a linked list at the end of the day. I mean, in my own opinion, I think that's like what I needed to do. So instead of doing final node, I'll just say, nah, this is not going to work. I mean, final node dot append, right? Append. I'm sure this is the only problem I have here is, you know, the form in which we are returning this. Is it going to be an array? Is it going to, do I need to create it like this? I hope this fails. Yes, it fails because that's, we want to return a node instead. So yeah, that is good. I mean, creating linked lists and adding all of this already, this is taking O of n time, right? And then this operation too will still take O of n time, which is why this didn't work. Let's see a solution here. So what this is, what's this? Okay, so while current, which is the head, right? If current of value is equal to 0, set a, what's the star? I just want to see how return the head. Tar on S. Oh, I see. So I mean, we can use this head, right? We can create a copy of our head and use this head as our, oh, okay, so we don't even need to, oh, I see. Oh, it's current and next. Oh, I see. So instead of doing it this way, instead of creating my own linked list, right, I'll just remove this, which wasn't really necessary. I didn't even think about it. Um, you know, oh, sorry. Okay, so I'll just comment this out again. So I'll create a copy of the head, right, and then use this to set you know, the current values each time. Somebody said hi. Hello, welcome to the stream. You're welcome. Have a seat and enjoy. Okay, so we need a local sum, obviously. So I'll just say my current head is going to, why do I need to keep it? Is that necessary though? I mean, current node is the head. Okay, yes. And I said while current value is not equal to 0, then we set this current the next. If current value is equal to 0, hey, you're welcome. Alright, so here this solution is such, I mean, s is equal to 0, meaning they are using x for the sum, right? Yes, S is the sum. Current to the next, right? Tar is equal to the current. So tar dot value is equal to S. Tar dot value is equal to next what? Is equal to S, which is the sum. So if current dot value is equal to 0, right? If current dot value is equal to 0, which is this part here, or this part here, right? If it's equal to, oh, this is like, I'm not sure. I'm not sure. How do I reply? Hello. He said namaste. Yeah, namaste. I think I've seen that online. I'm sure I'm doing it well, right? Okay. Is that okay now? All right. So we need something else to work. I mean, this one loop. So while the current value is equal to 0, nah, I don't want this. So what I'll do instead, right? Since this is a head, right, a head node, I'll just keep a copy, right? But would that not? Oh, I could do this. I could say instead of calling my final node this, right? I'll say my final node should be equal to the this head, right? Just to keep a copy of it, and I'll use this head to set my final node, right? I can just use this head and say, okay, this final node dot head, right, should be none. I'll say final node. Oh no, it's not going to work. Oh yeah, it can. Wait, why am I even stressing about this? There's this list node here, which is a node, right? So I can just say this is going to be a list node. I mean a node, yes, and I'll set the next value of this node each time. How about that? Final node dot okay, so instead of doing head, I'll just say final node dot dot next, right? Dot next, and say final node here dot next is going to be equal to this local sum here. But then this local sum will be a new node, right? List node. It takes a value, so list node lists this node. Hold on. Oh god. List node and put in the sum here, local sum. So hold on. So I'm using this final node as my list node. What is this? Should be 0. So I'll instantiate it with 0. I'll set it to 0 first, right? It's going to be 0, which is why I need to return next, so that it's the next value after 0. And every time I set this next, right, I need to reset it again. Final node dot next is going to be equal to a new node, right? I think yeah, something happened. So we're only adding 11 instead of adding 11 and and 4. So which means oh, okay, let me see. I need to replace. So instead of having this, I'll just say I'll keep a copy. Oh, this is not good. Copy final node, final, final, final node, right? So I'll keep a copy of my final node, and then I will just take. So every time I set, so instead of setting final node dot next, I'll just set copy dot next, right? It's going to be equal to this, and let's see. So this would change every time, but I still need to set the copy to a new copy. But I'm sure this should work. What's happened? Yes. Oh, sorry. So this copy is here, but then copy should reset every time. So copy node dot next, right? So copy is going to be copy is going to be copy dot next, right? So with this, yeah, okay, this worked fine. So let's see if this salvation is going to work. Hopefully it works, because I mean, what else can you do? Oh, yes, it did work, but the runtime is not really good. Oh, this took so long. Wow. I mean, oh no, this is not good at all, is it? It isn't, because so how do we improve this? I mean, in terms of runtime, it works. It works just fine. But like, ouch, my rib. Oh, wait. This works. This is a valid solution. In fact, I'm going to, um, I'm going to put like a comment here. I'm going to put like a comment here and say, LEETCODE version. LEETCODE version, right? And this should be mock version. I'll call this mock version, because this works, but in the case where you are trying to like have a time limit on how long the solution is supposed to run for, then this is a bad solution. But I'm still looking like, is there a way I can improve this? Like, can I improve this? Local sum, current node value, and so on. Blah 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 blah. This is bad though. I don't know. Will this improve? Is 964. That's a lot. 1000. I'll prefer to keep the previous one. Oh god. Honestly, I think there is a mistake on this question, because this question is actually easy. It's actually easy. Every person in the chat, right, in this place said it was. Let me have a look at somebody's comments. I mean, these people say, why is this medium? This should be marked easy, but for statistic, I mean, solved in 5 minutes without any help. Flexing. It should come easy. Just think of how you can utilize, 10 pointer to modify the list. Runtime error, Stack Overflow. 3 cannot be Solution is C++. What's this? I know I'm late, but for some reason I also face the same problem. Right? I'm used to long. I used long and long, and it worked. Test cases in this question are designed in such a way that they will be able to represent it in any int data type. No, okay, I'm not used to C++, so I don't know about this. Somebody did O of 1. Wow. O of 1 is easily achievable on this problem. Basically, you make a stack, okay, as an integer variable and create a dummy list node. When iterating through the list, if the value of the node is not equal to 0, add to the stack. If it's 0, first check whether or not the stack is 0, and if not, add the node to the dummy node. Basically, how is this O of 1? O of 1 in terms of what? Anyways, that's it today. This question has been solved. Christ, my rib. Okay, I'll see you guys tomorrow, and we'll continue with day. This is why solving questions are actually good, and practicing over and over again. If you look at this question, right, I solved something similar to this before, and I recognize this pattern here, right? So let me show you. I have something very similar to this. Where is it? Where's linked list? Yeah, I think it was when I was merging two linked lists. I would need to create a new exactly this here, creating a copied node. Yes, setting the list to the net. This is it. This was it. And this question was even more difficult than this question I just solved now. Anyway, I'm happy today that I was able to do this quite quickly. Sorry. So good night. Oh, let me add. Step by step, guys. We are going to get there. It's just beginners stuff. There's some questions. Some days are good, some days are bad. Well, hey, don't be hard on yourself. Merge nodes. Okay. I said I would be creating this is question 281, right? So I wanted to start using a format so I refactor this, rename leet right dash 281 dash merge nodes. Okay, and I will refactor this. Right, then I forgot to copy this, my LEETCODE version. Just copy. Practicing over and over. So I'll just keep this like this. Proper. Okay. I mean, we don't need to even validate this. We know it's an error. I don't have this optional stuff here. So piece off. Okay, so I'll just do this. I'll git add again. Sorry. Git add. Git commit -m merge right? Merge. It's a linked list question, so I'll say linked lists, right? And I'll do merge nodes. Merged. Oh, come on, merge dash merge nodes, right? Like this. Git push origin main 1 2 3. All right, that's it for today. Thank you guys for watching. I'm excited, and we shall continue tomorrow for it's already day 37 already. Wow, days are going by fast. All right, bye.